Hi guys, so this is my discussion 8 post. I apologize for it being late. It's show week for my community theater and it's been a hectic week. So I since my last name starts with N, I had the sample size of 160 galutes for both the weight and the care for offspring or not, obviously. So I'm going to jump ahead to these. So this is my histogram for this and my data, and then my histogram for this one and my data as well. So 27% of the galutes care for offspring, and the smallest galute weighed 3.9 pounds, and the largest weighed 2.7 or 22.7, my bad. And then on average, the average sample weight was 13.9 pounds. The standard deviation for this data was 3.85 pounds, and this means that most of the sample weighs between 10.5 and 17.5 pounds. And most of the weights of the glutes are within 3.8 pounds of the average weight. So we can see that from this histogram, we can see that the weight distribution is nearly normal. There is a slight skew to the left, but I'm going to consider it nearly normal for the purpose of this discussion. So like I said, the proportion was 0.27 or 27%. Standard deviation for this, the weight for the cares for offspring is 0.44, and the max is 0, and the max is 1 and the minimum is 0. And then so I went through, and then this is the multiplier. The standard area is 0.0351. The margin of error is 0.0577. The lower limit is 0.21 and the upper limit is 0.33. So this shows that the confidence interval shows that the values of P lie between 0.21 and 0.33. So then moving on to the weight of the galutes, like I said earlier, it was I considered it for the purpose of this a nearly normal distribution. The mean was 13.09. The standard deviation was 3.85 pounds. The minimum was 3.9, and the maximum was 22.7 pounds. And again, for both the weight and the cares for offspring, I had the sample size of 160. So for the confidence interval, the multiplier is 1.6545. The standard error is 0.3044. The margin of error is 0.5036, and the lower limit is 12.59, and the upper limit is 13.59, and that says that the confidence interval shows that the mean will lie between these two weights. So moving on to my hypothesis test, this is for the care for offspring. So I went through and did the steps. So I specified a null and alternative hypothesis. So just like Professor Barron did, I did 0.5 for the null and less than 0.5 for the alternative hypothesis. And so I checked if the model was appropriate, and it was independent observations, and we can assume that it would be less than 10% of the population, and there was more than 10 successes and 10 failures. So then I went and calculated the test statistic, and the z-test statistic is negative 0.528, or 582, sorry, no, negative 5.82, sorry. And so I took the I just lost my train of thought, but give me 1 second. I need to pull up my notes. So I took the sample minus the null mean, and then I divided that by the standard error, and I came up with the number of negative negative 5.82, and I rounded for mine. And so then we look and go find the p-value, and I calculated it, and as you can see from my data, it was like 0.00000003 or something, and you can see that it's 0 here. So I made the decision that since the p-value is so small that we're going to reject the null hypothesis, and then I came to the conclusion that the average weight is not 10 pounds. The data shows that the average, whoops, I went to the wrong one, sorry. So for the offspring it was 0, and so I rejected the null hypothesis, and that we can say the proportion of the glutes that care for offspring is less than 50%, and that is actually 0.27 or 27% of the glutes. So here's my standard normal distribution, and it's out here since the z-test statistics was at negative 0.82. So moving on to my hypothesis test for mu, the average weight. So again, I specified a null and alternative hypothesis, so I did it is equal to 10 and then not equal to 10. So I checked if the model is appropriate, and it does have independent observations in that we can assume it is less than 10% of the population, and that looking back, it has a nearly normal distribution. So then I went ahead and calculated the test statistic. So it was the t-test statistic, so it was the average weight minus the null hypothesis, and then we divided that by the standard deviation, which was, or the standard error, excuse me, no, yes, sorry, and then I got the number of 12.81. I think I, whoops, put the wrong graph in. 1 second. Yeah. So here's the actual one. I kind of messed that up, but so I used the t parenthesis 169 or 159 because I had the sample size of 160, and I put them out here to show that it is at the very edges of the distribution. So the standard error was 0.0395. The test statistic was negative 5.8186, which I mentioned earlier that I rounded mine, and then so our p-value was 0. So again, it was very small, so I rejected the null hypothesis. So we can conclude that the average weight is not 10 pounds, and that the data shows that the average weight is higher than that, and it is 13.9 pounds. So lastly, I found that both hypothesis tests that I ran ended in the p-test being very, very small, so we rejected both of the p-test. Thank you.